Welcome to this video, great to have you here. My name is Maximilian and in this video I want to get you started with AWS EC2. What is it actually, how can we use it, and how does it work? Let's take a closer look. On my channel I already got some videos on AWS and there we mainly used Elastic Beanstalk, a service provided by AWS to quickly get started with hosting web applications. Behind the scenes, and I did mention that in these videos, Elastic Beanstalk spins up some virtual servers using AWS EC2. EC2 stands for Elastic Compute Cloud, and what this actually is a service by AWS which allows you to bring up your own servers, you could say. Now, not of course complete machines, though you could rent complete machines too, but typically smaller fractions of these machines, virtual machines running on the physical servers. Though, and that's important, each virtual server you bring up is totally isolated from all the other software, basically all the other machines running on the same physical machine. And that is of course key from a security perspective. But let's take a closer look. On the AWS console, we can find EC2 under the compute section. Because since we launch our own server, our own machine, our own computer basically, we can of course do all sorts of calculations or computations on it. So let's click EC2 here and we're taken to the EC2 console. Now this console can be overwhelming the first time you view it. You got a lot of options here on the left, but the most important option for us is the launch instance button here. So let's click it. Because here we can bring up a new virtual machine, a new instance as it is called, which will be like a computer or a machine owned by us just sitting in the cloud on some other physical machine. The first thing we have to do here is, well, the same you have to do on your own machine in your own room if you get a new computer and want to set it up. You need to choose which operating system and which software to install on it. And you do this by choosing an Amazon machine image as they are called. There are loads of images to choose from, different operating systems and different packages of software which are installed right from the start. You can choose Linux and different Linux distributions. You can choose Windows. Now I'll choose the first image here, the Amazon Linux distribution, which already includes the AWS command line tools, Python, Ruby, and packages we can install for PHP and so on. So let's click select now. And with that we're telling AWS, hey, we want to launch a new virtual machine running Linux with the other software which was mentioned there. Now we need to decide which kind of machine do we actually want to run. Because of course we can decide how powerful it should be. And there are loads of options to choose from, as you can see from this list. Now this list is the next step where you can get overwhelmed. What is the right choice for you? Now basically all these versions, all these instance types you see here differ by the power they offer. But not just by the power in terms of memory or CPUs, but also in the relation these different components have to each other. So for example, we got the M instance type here. All these instances starting with M4 in this case. These are the general purpose machines, you could say, multi-purpose. M stands for multi-purpose indeed. And here we got this ratio of 4:1, so 16 gigabytes of RAM and 4 vCPU cores. And vCPU is a virtual CPU core because of course you don't have the real physical machine. You get a portion of that CPU which is actually installed on a machine assigned to your machine. So you get that. And other machines have a different ratio. For example, there are machines which are optimized on memory. These feature much more RAM compared to the CPUs they have. And that basically is the difference. That also leads us to that strange naming, which kind of tells you which ratio you have between the different assets or factors on each machine. I already told you that M stands for multi-purpose. C stands for compute, so these feature a lot of CPUs. As you can see, the CPU to RAM ratio is different than for the M instance family. That, by the way, is how it is called. This first letter describes the instance family, which in turn describes how RAM and CPU and SSD storage, or storage in general, is related to each other. So we got C instance family instances, which are more heavily focusing on CPUs, M, which is really multi-purpose, has a good relation for all kind of different tasks, and then we got other machines or other instances, like for example storage optimized ones. So where we have a lot of storage on these machines, like up to here 8 times 2 terabytes of SSD storage almost. And here you can really choose which type of machine you need for which type of task you want to run on this machine. Do you want to run a web server, a web host, or do you want to host your website on that machine basically? Well, then multi-purpose or these T machines here actually might be interesting. The T instance family stands for burst, and this actually works a bit different. There you can basically earn burst credits at times where the machine is not utilized that much, and then you can pull or use these credits if you got spikes, traffic spikes, which makes this really useful for spiky applications, spiky web applications. M, as I said, multi-purpose, also good web server. A storage optimized one, probably not so much. Might be better for other tasks where you need a lot of storage, temporary storage maybe. Or might be better, or other machines like with a lot of CPUs or RAM or GPUs optimized machines are existing too, which are better for big data analysis and machine learning. These are all things you have to decide when picking an instance. Now I'll go with the web serverish approach, and I also want to stay in the free tier, which allows me to use this instance for 1 year, all the time running, for 1 year for free. And check the free tier information on the AWS pricing page to learn more about this. This is only true if you have one of these instances. If you launch 10 of them, well, only one of them is free. So I choose the T2 Micro instance, which has 1 vCPU, 1 GB of RAM, no special storage attached to it. It does have internal storage, but we would have to add another service to get persistent storage, which isn't removed once we shut the instance down. And that basically is it. Now we could already launch it and just review the other configuration, but to really understand what EC2 is about, we should go through the configuration. So let's click on Configure Instance Details. On this page, we can now decide how many of these instances do we want to launch. I'll go with 1, we could add more, and we could automatically put them into an auto-scaling group, which manages the amount of instances depending on incoming traffic and so on. We could request a spot instance, and that is a different pricing thing or a different way of paying for them, you could say, of getting the instance too. Normally, what we're doing here is on demand. We're bringing this instance up, it is available, it's always available, and we pay the fixed price, which you can see on the AWS pricing page. However, there are 2 other pricing options. You could reserve an instance, which means you can't shut it down, or you can shut it down, but then you will still pay for it, which you don't in the on-demand usage we're setting up here. So you could reserve it, which is a bit cheaper, but you always have to pay it. Or you use the spot instance here, which means you bid for instances which are not required right now, but you only get them if the price basically approaches your bid price. And you are not guaranteed that this instance will stick with you. You can also lose it again. So this might be good for tasks which are not really time critical. You don't need an instance which is up all the time, but you occasionally need to run some calculation. Then this might be an option. So that's the pricing. What else do we have here? A couple of network settings, and I actually will have a separate videos on VPC and what this is about. Generally, this is your own network in the cloud you'll launch your instance into. You can then also specify subnets in this network, and that is what's happening here. You can also assign a public IP and use the subnet specific settings here, or you could set this to enable directly to make sure that this instance does receive a public IP. It of course needs one if you plan on reaching it from the web. Otherwise, if it doesn't have a public IP, no way of reaching that instance. You can assign an IAM role. IAM is this instance and access management thing on AWS, and with that role you can control what you'll be doing or what you'll be able to do from this instance. So for example, if on this instance you run some code to access another AWS service, you need to give that instance the permission to do so, and you can do this by assigning the right role. Shutdown behavior, well, what do you want to do if you shut the instance down? Do you want to stop it, which basically will not remove it, or do you want to terminate it, which removes it from your instance list? You can set up some monitoring details and you can move on to storage. Now here is some storage which is automatically attached to the instance. This uses AWS EBS, another service, and this is some storage which will also be available if you shut your instance down. The instance itself is a virtual machine and therefore it also has some internal storage, some internal hard drive storage. But if you ever shut the instance down, that will be lost too. And therefore, attaching some external storage to it also makes sense, because if you want to save some data which you want to keep, even in the case that you shut the instance down, you need that extra storage. And here is one storage device with 8 GB automatically attached to it. You could add more volumes, but you're going to pay for that too. And check out the AWS EBS pages, pricing pages, to learn more about that. You can also learn more about storage options here on that page. Next, you can assign some tags, which allows you to trace your instance, see it on the build, so basically to manage your instance. And then we have to configure the security group. Now that's important, of course. The security group decides which kind of security rules are applied to the instance. And you have to attach security groups to each instance. Now here we can create a new one or choose an existing one. I already got a couple of groups, as you can see. Basically, what you do in a security group is you decide which traffic is allowed to enter the instance and which traffic may leave the instance, which kind of requests. So a security group is a firewall, basically. You can decide which ports may be accessed from the outside and which traffic can, well, as I said, leave the instance. For example, here, what we're setting up as a rule is that we can SSH into the instance. So we use port 22, the SSH port. And then which source may do that. Now that strange notation here basically is a range of IPs, and I'll come back to that range of IPs in the VPC video. What this means here is everyone, the entire internet is able to SSH into your instance, and you don't want that. You don't want to give the entire internet access to your instance. Yes, there will be a password protection, but still, this is extremely dangerous. So instead choose my IP. To get your IP automatically entered into this field, and now only your IP will be able to access this instance and no one else. And this of course is super important because now only you from your machine can access the instance. Now if your IP changes and isn't static, you either need to adjust this every time you want to access the instance, you can adjust it after the instance was launched, or you need to set up a range here, which basically is the range of IPs you might potentially get. Now, setting up ranges here, you can simply Google for CIDR, C-I-D-R, translator or tool, and you will find a tool where you can enter IP ranges and get the right CIDR block. Again, I will explain this in the VPC video. So with that, we can now review and launch this. So let's glimpse over the details here again and launch this instance. And we're prompted to either choose a key pair or create a new one. Now this key pair is required for us to log into the instance. We can't log into it without a key pair, so make sure to download it and store it safely. If you ever lose it, you can't get it again and you'll be locked out from your instance. That's super important to know. So here I will create a new key pair and now give it a name, demo EC2, and download it. Again, you need to store this. I already got this, so let me name it demo2. I'll save it here. And now with that saved, you can now launch the instances, or the instance in this case. Now this will take a couple of seconds. You can go back to the EC2 console and actually see how it's getting launched. Here under running instances, you see, oh, it's already running, so that was really fast. You might still see pending there, but it really launches fast. And this is your instance, your own virtual machine running in the cloud. Now that's super awesome. But what can we do with it? Well, we can do anything we want with it. You can install whichever software you want to install on it. You can turn it into a web server. It does have a public IP, as you can tell down there. This is its public IP. And that is what you can do with it. Now, of course, if you take this public DNS here, which is like an automatically generated domain you may also use, if you enter this into the browser, you actually will see that nothing happens. And that makes sense because we haven't enabled port 80, we only enabled port 22 on that security group, so we're not actually able to send HTTP requests to that instance. but it does have a public IP. So turning it into a web server is only one thing though. You could run big data analytics on the instance. You could convert your vacation images into different file formats. You can basically do whatever you want. The only limitation, of course, is you won't have a desktop. You will have to connect to it over the command line, over SSH, or use some other tool for doing that connection, like PuTTY on Windows. Which takes us to the next step. Let's connect to this instance here. Now, how can we connect? I just said it, over a command line, over the terminal on Mac or Linux, basically. So let's open it and make sure to navigate into that folder where you stored this key file you just downloaded, because we're going to need this. Now I want to connect to this instance. Oh, and as a side note, of course, store this key file in a secure location on your machine and don't delete it, don't accidentally delete it. So now I want to connect to the server, to that instance. And on Mac and Linux, this is super easy. You can use the SSH command on your command line, on your terminal. On Windows, you don't have that. Now on Windows, there are other options, and I actually have a link about connecting to it on Windows in the video description. You can use, or you can install OpenSSH to also be able to use SSH from the command line. And or you can use a tool named PuTTY to also connect via SSH to that instance. So it's super easy to connect from Windows too. So with that here, we always, no matter if you're using Windows or Linux, we need to pass some information to our instance, basically. We need to pass the user with which we want to connect, and AWS automatically created one for us, and the password for this user. Now, the password is our key file here, this .pem file. This is our key pair we have for connecting to the database and to the instance. The username depends on which kind of image you chose. For Amazon Linux, it's going to be EC2 user. Now, the exact command to connect is the following. SSH, as you see, -i, then the path to your key pair. So in this case, since I'm in the same folder, it's just the name of the key pair, but it would be the full path to that key pair if you execute this command from outside this folder. Then your username, EC2 user for the Amazon Linux distribution, and then this public DNS we already copied. And then this is actually it. Now, if you hit enter, you can click or enter yes here to confirm the fingerprint of the instance. And now you see that the private key file was unprotected, and therefore we weren't allowed to connect to the instance. This is a security mechanism. We can't connect as long as our key file, this .pem file, is not protected. So as long as everyone can basically overwrite it. Now you can change the permissions of that key file to read only with the change mode command, chmod. Then 400, this is the shortcut for read only. And if this is totally new to use, simply search for change mode or for chmod, and you'll find detailed descriptions. I'll also put a link in the video description. And then the file name, so demo to EC2 PEM. Now again, for Windows users, there'll also be a link in the video description about how to connect to the AWS EC2 instance. With that file here adjusted now, we can now rerun this SSH command to connect to the database. And now you should successfully connect to it. And now it might look just like it did before, but actually you see here, this is now a different user. This is a different machine. This is us on our own EC2 instance. If you will list this, you see in that directory we don't have any files, but if you go to the root directory of that machine, you see there are a couple of folders and files here. This is definitely not my machine, I can tell you that. This is this Linux instance we're running in the cloud. And we were able to connect to it because we opened the 22 port for our IP. Now this is the instance running and we are connected to it. And as I said, you can now do whatever you want to do. It is like our own machine. You can install whichever software you want to install, run whichever code you want to run. It is your machine now, at least until you shut the instance down, and you can turn it into a simple web server, convert any images to smaller images there, do big data analysis, whatever you like. Now, in the video description, you'll also find a link how you could turn this into a web server. It's a process which involves multiple steps. You have to change some permissions, but this is something you can do, might be a nice next practice. This is how you can log into your EC2 instance. Now let's go back to that management console. Here we see all running instances. The one we just launched is the only one I have here actually. What about all these settings here on the left though? Well, you basically see some reserved instances and spot requests. These are the different pricing options I mentioned. You see some general events tags, some logging, information about your running instances. Here is a section about all the images you might add to your own image collection. So the image we used for setting up this instance basically. We can manage our block storage. This is this EBS service I mentioned regarding the storage we have attached to our instances. There's only this one volume we did attach to the instance we're running right now. We also have this security group setting, which is about all the security groups. And this is what I actually also want to take a look at right now. Here, this is the security group we created last. And if we increase this here in size, we have a short description, which isn't too meaningful. There is this VPC thing, but I'll come back to VPC in a separate video, as I said. And then here, inbound and outbound is interesting, especially inbound. Inbound is how you manage what is able to access your instance. And this should be as strict as possible, of course. Here, only SSH access is possible. You can't access this instance from the web, for example. And even the SSH access is restricted to our IP here. This, of course, should be as secure and as strict as possible to protect your instance. The outbound rules, on the other hand, are very relaxed. Here, all traffic is allowed to access anything. You may restrict this too, but in general, this is not as critical here. And we definitely want to give our instance here access to the internet in some way, of course, at least, because we want to ensure that we can install updates and so on. This is our firewall, the security group attached to our instance, and definitely important to understand that inbound rules should be as strict as possible. Elastic IPs here are an interesting concept. Your instance here, if you have a look at it, if you click on it, does have a public IP address here. Now, this public IP4 address here changes each time you shut the instance down and bring it back up. So you can't rely on getting the same IP again. And of course, if you have a website where you route your traffic to that IP, that might not be the behavior you want. Actually, as long as you stay in the AWS world, there are ways to work with dynamic public IPs too. But it might still be something you want to look into, elastic IPs. Even though the name is deceiving, elastic sounds very dynamic, but actually these are fixed IPs you can allocate to your account, and you do have to allocate them because IPv4 addresses are a rare resource. It's changing with IPv6, of course, but we're running out of IPv4 instance IPs. So you can allocate some to your account, only a limited amount, and then you can assign these IPs, which now really belong to you, to your account, to instances. And even if you shut an instance down and bring it back up, you will still get the same elastic fixed IP address. So that is really an interesting concept and really something you have to keep in mind if you are running applications, web applications on these instances. Now, load balancing and auto scaling is something I already touched on in my Elastic Beanstalk video. Basically, it allows you to distribute incoming traffic across all instances or bring up or shut down additional instances as the traffic changes. And then you get some, advanced management options here to get an overview over your instances and so on. So I won't go into too much detail here. This is what you can do with EC2. Now I'll conclude this by shutting this instance down by clicking on it and then either right-clicking instance state terminate. You could also just stop it, which won't get rid of it, or reboot it, but I want to get rid of it. So terminate would be the right choice, or you just select it and click on actions, and then you have the same menu, instance state terminate. Now we're warned that the EBS volume is configured to also be shut down. You could now change this, but I will also shut down the block storage, which means, of course, that everything I stored there is lost. Everything here is lost. The whole instance will be removed, and I can't access it anymore. This is how you bring it down, and I hope that in this video, I could give you a brief introduction, relatively brief introduction to EC2, how to work with it. Again, we already worked with it indirectly through Elastic Beanstalk in an earlier video, but it is really important to understand what's happening behind the scenes, and I hope that this worked with this video. See you in other videos. Bye.